Okay, this now we're going to be reviewing graphing of reciprocal functions to get ready for our next summative. So we always consider the parent function. It's the general function before it gets translated or transformed. So this is a hyperbolic function, 1 over x. So basically it's going to approach Okay, so there we go, we get 1 over x, that's our reciprocal function. Our vertical asymptote there is x equals 0. Our horizontal asymptote is y equals 0. And so our domain is going to be x such that x cannot equal 0. And y is going to be y such that y does not equal 0. So, we'll take a look here. So for instance, if we're going to just transfer that down, we're moving it to left 1 and moving it down 5. So that's what this told us. So the vertical asymptote here is going to be whatever makes the denominator equal to 0. So it's x equals -1. Or horizontal asymptote, you could see here, is going to be, well, this is going to go to 0, so you're going to get 0 minus 5. So it's going to be y equals -5. All right, so you're going to have x equals -1. So you have this guy right here. Okay, and then you have -5. Okay, so you have this guy down here like that. Alright, so our asymptote, so it's going to come down like this. Okay. Alright, so that's our graph right there. So our domain is going to be x such that x does not equal -1. And our range is going to be y such that y does not equal -5. Standard form, here of our function is going to be f of x is equal to, in other words, I'm talking about the parent function being transformed. So the standard form of way to do that is write it as such. Remember how we have h was the horizontal shift, right? And the plus is going to make it go left. The minus is going to make it go right. The k, you might remember, is your vertical shift. The plus is going to make it go up. The minus is going to make it go down. If a is negative, the function is going to be reflected over the x-axis. So if a is negative, it's going to be reflected over the x-axis. Sorry about that, I'll bring it down. So I just said that if a is negative, then the function is going to be reflected over the x-axis. If the absolute value of a is greater than 1, then it's going to be stretched. It means it's going to get skinny. And the absolute value of a is between 0 and 1, then it's going to get compressed or be wide. Vertical asymptote, well, that's going to be x is equal to whatever this h is. And our horizontal asymptote is going to be y, whatever the k is. And that's the general format. You might remember taking notes on that. So again, the purpose of this is to view our graphing, get us kind of ready for a quiz and go over some more graphing. So for instance, if we have number 2 example here, we know we're going to go to left 3, we're going to stretch it, and we're going to reflect it over the x-axis. So what do we know? The vertical asymptote is going to be y equals k. So, the horizontal asymptote is going to be x equals h. So x is equal to -3. And yes, so horizontal asymptote is y equals k, and k is 0 in this case. So we have x equals -3. Y equals 0. Alright, we got that, and our domain is going to be x such that x does not equal -3. And our range is going to be y such that y does not equal 0, so we know that. Okay, and then how do we graph the points? We got to pick some points that make sense. So if we put in -2 there, let's say put x equals, and this will make a little chart x and y. So put -2 in there. I'm going to get 1s. I'm going to get -2 also. So -2, -2 will be a point. -2, -2, right there. It can't be negative 3, so say negative 4. Put negative 4 in there, that'll be positive 2. So you see a little symmetry brewing up there, so try negative 1. If I have negative 1 in there, I'm going to get negative 1. And if I put negative 5 in there, negative 5, that'll be negative 2 over negative 2, so that'll be 1. So you can begin to see the graph take shape. You just plot a couple key points and note that it's you know that it's going to be reflected over the x-axis, so that's why it's not the first and third quadrants like the parent function is. You see it's over the x-axis. We make an inversion because a is negative. It's also stretched out. It's a little hard to tell that it's stretched out, but it's supposed to be like wider. You know that because the absolute value of a is greater than 1. For the rational functions, the equation form of rational functions looks like this. It's f of x is equal to p of x over q of x. We learned that. And the x-intercepts are when we set the numerator p of x equal to 0. Okay, and the vertical asymptotes are when we set the denominator equal to 0. Denominator q of x equal to 0. Okay, equal to 0. Alright, so what have we learned here? Horizontal asymptotes, if the degree of p is greater than the degree of q, then we have no horizontal asymptote. If the degree of p is greater than less than the degree of q, then we have y equals 0, the x-axis. And if the degree of p is equal to the degree of q, then it's going to be leading coefficient. So it's going to be the ratio of the leading coefficient of p of x over the leading coefficient of q of x. Leading coefficient is what I'm saying LC is. Alright, the holes. Don't forget the holes. That's where the breaks in the graph. And the x-coordinate. That's how do we get that? We set the common factor equal to 0. So we're looking for common factors. Set common factor equal to 0. We have to have a common factor. If you don't have a common factor, then you're not going to have a hole at all. Equal to 0. And the y-coordinate, you substitute in the x-coordinate. Substitute x-coordinate into the simplified function. Now over here for 1, let's do some examples here. An example. So what would you do here? You'd factor out the numerator, difference of squares, x plus 3, x minus 3, and then be over x plus 2. Now there's no common factors, so we should not have a hole. So no holes there. X-intercept, what makes the numerator equal to 0, so you're going to have x equals negative 3 and x equals positive 3. So that's going to be negative 3 comma 0 and 3 comma 0. Vertical asymptote, that's going to be whatever makes the denominator equal to 0, so that's going to be x equals negative 2. And we'll finish this here. So that means that x equals negative 2 is right here. Alright. No holes. We have an x-intercept of negative 3 comma 0 and 3 comma 0. There we go. Our domain is going to be all x such that x does not equal negative 2. Horizontal asymptote, none. We have none because the numerator has a higher degree than the denominator. And so our range could be anything here. Y is not limited at all. So you have to put some numbers in to figure out where that goes. What do we know? So we know it's got to kind of come in here like this. And we know it's got to go through this point. So we can plug in a couple points for the sake of simplicity. I'm just writing in there for you, but you would make a little chart of x and comma y's and put them in there so you have some guide points that you know the graph has to go through. That's what you would do. All right. And for number 2 here, factor this guy out. So you'd get x minus 5 times x plus 1 over x minus 1 and x plus 1, right? And so we could divide out a common term of x plus 1, so you're going to get x minus 5 over x minus 1. So then you're going to get a whole at negative 1, because, oh, positive 1. Yeah, sorry, it's x, this is x plus 1, so it's x negative 1, that's right, negative 1. So negative 1. And then you put negative 1 back in here, and you're going to get 1 minus 4 plus minus 5 all over putting, well, it's going to be, if you put that back in there, oh, sorry, my bad. You're putting 1 back into the, negative 1 back into the simplified function, you're going to get negative 6. Negative 1 minus 1 is negative 2, so you're going to get 3. So therefore, our whole is negative 1, 3. Our x-intercept is what makes the numerator equal to 0, so that's going to be x equals 5. That's 5, 0. Put that down. 1, 2, 3, 4, 5, 0. We know that. We know there's a hole at negative 1, 3. So negative 1, 1, 2, 3. We know there's a hole right there. We know that there's a vertical asymptote. Do we know that? No, the vertical asymptote is going to be x equals 1 because that makes the denominator equal to 0. So x equals 1. Excuse me. Vertical asymptote. Yeah, x equals 1. Vertical asymptote x equals 1. That's correct. I was right. Just second guessing myself. And then the horizontal asymptote, since we have common degrees, it's going to be 1. So it's going to be y equals 1. All right, let me plug in some points. So we'll do that. So our domain is going to be all x such that x does not equal 1 or negative 1. So it can't be 1 because of the asymptote, and it can't be 1 because of the hole. The negative 1 would be negative 1 because of the hole, and it can't be 1 because of the asymptote. And the range is going to be y such that y does not equal y does not equal y does not equal 1 or 3. Now y can't be 3 because of the hole, and y can't be equal to 1 because of the asymptote right there.